We've eliminated the portions of sunlight and essentially the amount of sunlight we're getting during the day, and we've moved it into the night, and it's essentially affecting all life forms.
Okay, hello everyone. Welcome back to the Regenerative Health Podcast. In this episode, I had the absolute pleasure of interviewing Scott Zimmerman. Now, Scott is an optics engineer and light researcher who has basically been studying the effect of infrared or non-visible light on the human body. He has made some fascinating and quite unexpected discoveries about the way that our bodies use this infrared light and how this affects the creation and the manufacturing of melatonin, particularly where exactly these sources of melatonin are being made. And what he's discovered, I think what you'll hear in the interview is fascinating. This is sometimes quite a complex interview, but it is incredibly interesting, and it goes very well with my Jack Kruse series. So for those willing to and interested in delving very deep down the rabbit hole, then this one's for you. If you're enjoying this podcast, share it with someone who might find it interesting. That would very much help. So thank you and enjoy. So let's get started with a bit of background on yourself and how an engineer comes to be addressing such fundamental questions about light and human biology.
Well, my background is I've spent 40 years in optical design for displays and lighting. I have 85 issued patents in the area. And a few years back, I started looking at lighting. I was trying to develop I got very interested in some work by Dr. Hamlin and others on red light therapy and photobiomodulation. And one of the things I noticed is that a lot of the levels that they were using and showing biological effects were levels that we used to get, at least in the near infrared, as far as milliwatts per centimeter squared, when we had a well-lit incandescent room. Most people aren't aware about, but both sunlight and incandescence have the majority of the photons that they emit are in the near infrared. And so I got looking at it, and I came to the conclusion that I started trying to model, what is all this stuff doing in the body, because I do quite a bit of optical modeling. And I was lucky. I ended up talking to Professor Ritter down, and he's an expert in melatonin, and we kind of started to collaborate and have a series of papers with each other. But what I found is that, people think they understand light from the standpoint of we can see. Most of us are lucky enough to see. And that makes us kind of an expert in light, but it's only the visible light, and that represents only about 10% of the solar spectrum. And what you start looking at the problem from an optics standpoint, there's very little data and very little work that had been going into how light actually interacts with the body. So as an optical engineer, I started modeling various things, and previously to this, we didn't understand how light propagates in the body. And in particular in the near infrared, it can go several inches into the body. But more importantly, what you start to see is that the body has all these different ways that it goes to great lengths to actually collect and localize light in very specific tissues. People think, retina. Well, it turns out that for the eye, the majority of the photons that hit the retina don't go through the pupil. They actually go through your eyelid and through your sclera. And the vitreous humor in the eye actually has a broader transmission window in the near infrared than it does in the visible. And you start asking, once you start doing that, you find that, okay, so light actually propagates through the skull and goes into the cerebral spinal fluid and is light trapped, light guided down into the fissures of the brain. Why? Is it just happenstance or no real reason? And the more you look, you see all these amazing ways in which the body actually takes advantage of sunlight And Professor Fosbury over in England um, has a series of pictures that I think I just put up on LinkedIn, some of them, but where he shows, how in the near infrared light propagates deep into the body, localizes in the blood vessels. And you have to, once you start looking at the optics of the body, you start to ask yourself, why? Is it just for no reason? And that's when I started working with Professor Ritter, and he started showing how, he's been for 40 years, he's been a proponent that melatonin is being generated in mitochondria. And so we have a series of papers around that and kind of show that if that's true, which it appears to be true based on our latest work, then, sunlight is doing some pretty amazing things to our hormone levels as well. Most people can understand sleep disruption and things like that, but just the process of walking outside, optically, the body is localizing that near infrared in particular in various places in the body so that it's always guaranteed that you're never exposed to visible light or UV light without that excess of near infrared. And so that's kind of where we're at right now. Um, so as an optical engineer, I approached it that I like to quantify stuff. And so our original work started out with, okay, we'll model the optics, where the photons are going in the body. And then we combined electron spin resonance data to then convert that into a three-dimensional profile of free radical generation in the body. And then if you know something about the free radicals, then you basically get to the point of saying, well, what's the response, which is antioxidant. And so you start to see these, like I say, these amazing ability of the body to take advantage of our surroundings. And that's kind of where we're at right now. And, I guess long way around answering a question, but
No, that's fantastic, Scott. And I'm always very, very interested in talking to engineers who have branched into biology and into medicine and health sciences, because the rigor that you apply to our field as doctors is incredible, and it's a very, very unique and fresh perspective. We will definitely talk about melatonin maybe later in this discussion, and yeah, as you mentioned, the fascinating implications of this compound and what it's doing in the body. And look, a lot of my listeners will know of melatonin is what they buy in the chemist after they've had a long flight to reset their kind of their jet lag. But there is so much to melatonin that I really want to dig in with you. Before we even go there, I'd really like to take it back to a very, very basic level. And forgive me for really simplifying or getting you to explain things really simply, because a lot of my audience, this is the first kind of introduction, or that we're just getting started in terms of understanding how what light is and how that is affecting the human body. So you mentioned, we've mentioned visible light, we've mentioned non-visible light, and we've mentioned wavelengths, and we've mentioned photons. For the complete layperson, just describe to us what is a photon, and how does that relate to the different types of light that we that exist.
okay. I'm not very good at this, but I will try. Um, but no, first you have to understand that sunlight it has a very broad spectrum. When we walk outside, it goes everywhere from UV into far infrared, and that's a very large. We call that the spectrum, and kind of like the rainbow that people see, there are different wavelengths. So, if you're dealing with blue, it's 400 nanometers. If you're dealing with red, it's 650 nanometers or something like that. But sunlight runs from 280 nanometers, at least on the ground here in Austin, wherever you're at. 280 nanometers out to beyond 3,000, 4,000 nanometers. But the eye only sees a very narrow portion of that. Okay. And so when, you experience being out in the sunlight or in artificial lighting or whatever, your eye really is only typically exposed to somewhere between 400 nanometers, nanometer being the wavelength of the light, and 700 nanometers. So it represents what we can see is only about 10% of what sunlight actually provides to us. And that being said, um, you know, a photon basically is just a packet of energy. And so at each wavelength, there is an associated amount of energy in that photon. At higher or shorter wavelengths, the energy per photon is much larger than the energy per photon in the longer wavelengths. Okay. And so you have to start, instead of thinking as light as something continuous, you actually have to start thinking at it what they call the quantum states. But bottom line is that the little parcels, they're just a whole bunch of little parcels. And we're talking about, a typical walk outside situation. You maybe have 10 to the 20th photons per second hitting every square centimeter of your body. So there's just so many of them that it feels like a continuum. But when you start looking at that, all the different wavelengths and energy levels, then you can start counting them basically. And you can assign, hey, here's how many photons are coming here every second, how many photons are coming there every second. And it's a function of wavelength and a bunch of other stuff. But, I guess I'm trying to say, think about the rainbow. It has different wavelength range, but then magnify that way out to where you got like 4,000 nanometers of bandwidth or spectrum to deal with. And so
Yeah, and that's all natural terrestrial radiation that's coming from the sun. And in some previous podcasts, we've talked about other sources of radiation, so-called non-native. And what we mean by that is that sources of radiation that don't have an origin from the sun, that we didn't evolve next to. So I guess I just make that distinction for the listener, is that what we're talking about particularly at the moment is the radiation that's coming from the sun, and we're only seeing a small, I guess, parcel of that window
yeah.
of that energy that's hitting the Earth. The next question, which is what you alluded to a little bit at the beginning of the conversation, is that these have very, very unique and different effects on our biology, depending on the wavelength of light. So maybe can you give us a bit of an idea? Maybe I'll start, and if we go to the bottom of the wavelength, the ultraviolet, at its core, ultraviolet C radiation doesn't make it through the atmosphere, but ultraviolet B radiation is how we make vitamin D, and it basically photoisomerizes a D7-dehydrocholesterol in our skin to make vitamin D. I mean, that's one of the biological effects of that particular wavelength. So to talk us through some of the other biological effects of the different wavelengths, and particularly the ones that you've been researching.
Well, to stay with UVB for just a sec, there's this really great paper by Yakimov where he actually used Raman microspectroscopy to actually determine what's the composition of the outer 50 microns of the skin. And, as you say, 285 is necessary to oxidize cholesterol, which is then used to make a whole bunch of different hormones in the body. The problem is, or what I think is optically amazing is that what the Yakimov showed is that outer 50 microns in everybody, independent of their skin color, is, when we're outside, is actually photochemically oxidized. And what he showed is that we've got this ultra thin layer, and the whole point is that it's photochemically bleaching that outer part of the skin, so that it's more efficient at allowing 285 to come into that region and break up cholesterol, which we need for vitamin D. So by eliminating, not having the full, and what the data shows some work shows is that that outer or that process requires or uses takes advantage of hydrogen peroxide generation, which has been shown to require the UVA, visible, and the near infrared to do that efficiently. So when we don't get outside, we're essentially reducing the efficiency. When you're talking about trying to crack cholesterol, it's only about 8% efficient process in the best of days. It's really kind of hard to do. But the body seems to have developed this outer, that nobody seemed to know anything about, this outer microreactor that is optimized when we're outside to more efficiently break down cholesterol or oxidized cholesterol. And so, what you find is the more you look, every time, what would happen is I'd do an optical model of something. And then I'd start looking at, well, wait a minute, what's that doing? And the more I look, then you start to look at the biological responses and you say, oh my gosh, there's actually something going on. And, that's, what's been driving a lot of from an optics standpoint, it's been driving a lot of the work I've been doing is to just simply understand what the body's already doing. And the thing that people have to realize is that in our modern lifestyle, we took away the near infrared and the UV from our indoor environment. And when we did that, then all of a sudden the body doesn't have the ability to do this photochemical bleaching, doesn't have the ability to localize near infrared in the retina or stimulate tear production or all these other things that, it was the elimination. And you got to put it in perspective from the standpoint, the elimination we've gone through is the largest reduction in solar exposure in human history, period. We walk into a room, the windows are blocking near infrared for low E glass. They're blocking UV. We sit in front of a display that has only visible light coming out of it. We have lighting that has only visible light, and we spend 93% of our time in that environment not being exposed. And what I've been kind of focused on trying to do is show that there's all these different things that the body's doing that nobody knew. I mean, until we did the model, nobody knew that you could, that the near infrared component would actually penetrate through the skull, get into the cerebral spinal fluid, and be light guided down to the gray matter, which just happens to be on the outer portion of the brain. And now we're starting to show that, the variety of other things. I keep on saying, pregnancy, I have 5 kids, but I had a set of twins. And it was just amazing to watch the progression through the pregnancy. And when you look at that optically, it's just what happens is in the early part of the pregnancy, the mother's skin blocks the UV and the visible. Now understand that UV and visible, the higher, the blues and the greens, have enough energy to essentially come in and break a molecular bond. And so you don't really have the choice. The body doesn't know where that bond's going to be broken and forms a free radical. So, the shorter wavelengths, the body is very discretionary on how it lets it come into the body. But when you're in the first part of a pregnancy, essentially the blues and the UV are all blocked by the mother's skin, but the near infrared passes through. And it turns out that the amniotic fluid surrounding the baby has a peak transmission at 850 nanometers in the near infrared. And that, as the progression of as the pregnancy progresses, the mother's skin gets taut, stretching, to the point that you're allowing more of the other wavelengths to come in. And it appears that that's an important part of the baby's eye development, you start looking at the other parts of the body. I mean, one of the things that I think is the most amazing is that, if you look at Fosbury's pictures that he's done at 850 nanometers and other places, you see how the body essentially just lights up, and the near infrared bounces around inside your hand or whatever. And but it localizes that scattering optically, allows it to actually get to make sure that the blood vessels which are very important in the near infrared from the standpoint it actually we've been shown that it's been shown that that increases blood flow, oxygenation, cytochrome C, all these good benefits are associated, and the body literally optically scatters it such that it gets distributed throughout all these little microvessels. And kind of like, we've got a radiator system on the outside of us optically. And so there's all these different mechanisms that nobody seemed to have ever looked at.
It's
And when you look at them, you're just kind of like in awe.
incredible. It's absolutely incredible, Scott. And I like to talk to patients about this idea of optimizing their food diet and their light diet. And what you described in terms of the change of people's light environment over the past 50 to 100 years, to analogize, it's like if we suddenly only ate food that was stripped of 80% of its nutrients, or equivalent.
Yeah.
That is the analogy for what people are doing when they're living an indoor existence and they're depriving themselves of natural sunlight exposure. Is that, as you say, we've lost the non-visible light below, so ultraviolet, which is below visible, and we've lost the non-visible light, above visible, above red. So as you just previewed for us, they have very, very critical and almost up till now unknown effects on our biology. But by becoming indoors and by exposing ourselves just to blue lit LED downlights and computers, we're essentially stripping down our light nutrients to a fraction of what we evolved and what we need. I really want you to expand upon on what you've just talked about in terms of how the body is using near infrared, and maybe before we delve really deep into it, can you explain to us the difference between infrared and near infrared?
Well, unfortunately, before we knew what was going on biologically, we assigned different uh, names to parts of the spectrum. And so the near infrared is typically the portion that you start at red, deep red, and you go out to anywhere from 1200 to 2000, depending on who you're talking to. And then from 2000 on out, it's what's called shortwave infrared, and then there's far infrared. But they're really just names that were assigned based on not understanding what was going on in the body. In the body, by the time there's these what they call biological windows, where, starting at around 630 nanometers, which is kind of an orange red, out to about 1200 to even beyond 2000, is an area where the body has very low optical absorption, and the scatter characteristics, how the light, you take that's a good way to think about it. Basically, the way the photons are actually spreading in the body, in that region, there is most of the spread let's put it this way. If you have a white shirt on, okay, most of the light, because it's nice and white, is being reflected back, scattered back to you. It's not being absorbed, it's just being scattered back to you. In the body, in the near infrared component, and even into this shortwave infrared component, there is an effect of mostly what they call forward scatter, which that allows you optically the photons to actually spread, but they don't come back at you. They don't bounce back as much. And the absorption and the combination of that forward scatter is what actually allows the light to propagate. And I don't know if you've seen some of the Roger Seaholt's videos on light as medicine. It's based on some of our work,
Oh wow,
but
yeah, yeah, yeah.
yeah, and he shows some really great photos where in the old days, before everything, medicine was in the older days of medicine, people would take a red light, shine it up here, and they'd actually look and see whether or not the sinus was occluded, going through the bone and all that. Anybody who's told ghost stories on Halloween and stuck a flashlight up in their mouth or out their nose knows that the entire thing lights up. But if you read the literature, because they really didn't bother to model it correctly, people talk about, near infrared only having a penetration depth of a millimeter or something like that. And the problem is they're not actually looking at the characteristics of the body properly, and not taking into account a thing called et and do and a bunch of other stuff. But anyway, um, but what we're finding now is that we can actually model that effect, and what you see is that you have this propagation of this window of near infrared deep into the body, and such that in a child, and this is one of my big focuses is children, is that a child is small. That means that a high penetration depth, or the amount of how far the near infrared will go into the body, is much higher. So the higher number of cells are affected by children, affected in children compared to adults. Still a lot in adults, but in children in particular, right when they're in this growth mode and all this other stuff. It used to be that the kids would go out and build a tree fort or whatever outside. Now everything is, they go into a building with artificial lighting and have sports or something. So I think people don't really understand or realize how much we have changed this whole environment. And the near infrared in particular is extremely important. But as I said before, it's not just, everybody wants to have a single item, I don't eat avocados, I live longer type thing. But with this type of situation, it's all complementary. You talk about, we want to have a lower diet, you are a better diet, or we want to, um, get take this particular set of vitamins or whatever. They're all complementary from the standpoint of they all have an effect on your cellular, how your body functions. But for whatever reason, I guess because people can see it, light is never on the list of things that you want to care about, and that's what I guess I'm trying to get people to realize. And
Yeah, no,
you brought up,
so
go ahead.
so no, definitely. That's, I think this is the message that I'm trying to promulgate as well, which is that light is having an amazing effect on biology, and if it's done wrong, i.e., if we have a junk light diet, then we're going to get sick. And if we respect our the evolutionary biology of our needs for an evolutionary appropriate light environment, then we're going to thrive. I'll include Roger Seholt's video in the show notes. That's an amazing, very informative video called "Light is Medicine." He's the doctor from MedCram, so I'll definitely include that. It's very, very informative. So let's expand upon what you were talking about, with the concentration of near infrared photons. So if I'm correct, in terms of paraphrasing you, Scott, basically what you're saying is that the body has evolved ways of taking this non-visible light, which is above the red spectrum, and absorbing it into the body, and then transmitting it, from the point that it's been absorbed, throughout the organs. And you mentioned the brain, which are the sulci, which are the curves within the brain, and you mentioned into the cerebral spinal fluid, which is the fluid that bathes the spinal cord and is continuous with the fluid that bathes the brain. Is that correct?
Yeah, well, I'd be a little bit more specific from the standpoint. Most of what happens is in the near infrared there is a low level of absorption, and as Fosbury puts it, essentially it's a low absorption matrix with a bunch of weak absorbers in it. So imagine you have like a snowdrift, and you've got in there a bunch of little asphalt particles. It the light, when you're sitting there in your little igloo, the light propagates through there quite well, but you still have these absorbers in there, which are the cells, the mitochondria, and all that. And so all I'm saying is that a higher percentage of, in the near infrared, a higher percentage of those cells or those absorbers are being affected by are able to absorb the near infrared components, because it's not absorbed as well. And so you get this amazing effect where you get this propagation of photons deep into the body, And what happens is the body has, over the years, developed some pretty amazing optical mechanisms to make sure that it goes to very specific places in the body, like, as I say, the gray matter, the fetus, the blood vessels. And so just from an optics standpoint, it's really quite fascinating. The other thing you have to take into account is that most of the research that is done and arguments done for sunlight assume you're in direct sunlight. The most amazing thing about it is that I don't know if you've ever seen near infrared photography.
No.
Okay, so what you can do is you can actually get your cell phone modified or a little camera modified, and as I said, the near infrared is larger wavelengths than red, out to 1,200 or 1,000 nanometers or more. Okay, if you take pictures in that region, you'll see that we're actually walking around you're in the forest. All the trees and leaves are reflecting. They look like they have snow on them because they have extremely high reflectivity in the near infrared. So what happens is that when sun comes down and hits your surroundings and reflects off of it, in the visible, it's absorbed. That's what gives us the ability to tell that the apple is red and the orange is orange, and lemons are good and that snake is a bad idea. Those are the things that we need to be able to survive. But in the near infrared, everything's white. Virtually everything is white from that's living, grass, leaves, reflecting clouds. And so we're actually walking around in this kind of like an integrating sphere. And the fact that we walk upright optically means that a very small, what they call a solid angle, hits your body when the sun's above you. But all surrounding you is reflections from that sunlight in the near infrared, absorbed, dropped down to 80% of what it is to make the leaves be green and all that. But in the near infrared, we're walking around and the body is accepting all this from all different directions. And that's one of the things that's just, I find most fascinating about it. Our upright position of walking increases the amount of near infrared we're exposed to. And, that depends on, even dirt has a higher reflectivity in the near infrared than visible. And so, it's kind of like, did we start walking upright because we had other reasons, or do we walk upright because it gave us more near infrared? You can always make that argument. But,
Incredible.
well, it is because, it's something that people don't know anything about. And, they feel it as heat maybe. And if I could take just one quick second, I know it's a little bit off in the woods, but heat, one of my pet peeves is that everybody just says infrared, oh, that's heat. It is no more heat than visible light or UV light. A watt of UV, a watt of visible, a watt of near infrared, they're all got they're made up of photons, and we tend to try and lump all this near infrared and shortwave infrared into this thing of heat, and it is not heat. And the body is responding absorbing and responding in a way that is very, very interesting in a lot of ways to what's going on.
Yes. So I guess the question that I have then is, if we have evolved these biological characteristics, so you've mentioned perhaps upright stance, you've mentioned an ability to concentrate near infrared photons into the grooves of the brain. If we've evolved amniotic fluid with a specific does it refractive index to promulgate these near infrared photons? The question that I guess I'm interested in is why exactly that is the case. And to me, it sounds like what is happening is that the most sensitive tissues that perhaps have the most energy requirements are being facilitated to absorb this type of light. Obviously, the growing fetus, obviously the gray matter, which commands an insane amount of energy consumption. So what are your ideas about why these biological features are as they are?
Well, I mean, there's, well, like right now, why don't you have hair on your forehead? You know, if you look at it optically, that hair, while the fact that you have that and allows an ideal amount or an increased amount of near infrared to penetrate and be in your frontal cortex. That's one thing. You have eyebrows that are in a certain location. You have your eyes recessed back in your sockets. You start to see from the standpoint of how the body is constructed that it's trying to guarantee that you get a certain amount of this near infrared into various, as you say, sensitive tissues. And part of the reason is that there's been work by Kessler and others where they show that once you get exposed to near infrared, the blood vessels actually, there's an increase in oxygenation hemoglobin. There is an increase in blood flow associated with stimulating nitric oxide compounds in the blood vessels. So one could argue that the body made a choice eons ago that it's going to use the near infrared because it goes so deeply into the body to essentially stimulate waste removal, you know, increase the amount of, if you have increased blood flow, then you can argue that that various immune functions are enhanced. Like I say, even to the point of determining how efficiently we generate vitamin D and all the the cholesterol that's being cracked up at 285 is being used by the body to do everything from vitamin D to sex hormones to, cortisol to a number of other different hormones. And that's kind of what we started out. I started out with mainly doing the optics and trying to understand where the photons were going. And then when we were able then to add the electron spin data to get free radicals. And people have to realize that free radicals are not always bad. Free radicals actually drive life in a lot of ways. And so, but they have to be kept in check and in balance on a level that is both globally or systemically, but also mainly locally. And that's what, when you start looking at it optically, you're counting the number of photons that are hitting a cell, type thing. And you look at it and you go, holy cow, that's generating all these free radicals in a second. How in the heck is the cell surviving? And, quite honestly, some don't, from the standpoint of, every 20 days our skin cells shed off as a sacrificial layer because they're taking on all these free radicals that are being generated in life. And, that's kind of, you start to see that there's kind of the body doesn't get just to optimize around one item. It has to optimize multiple things. And trying to survive is getting the best combination. And, I was listening to the conversation or a Netflix thing on the blue zones and the discussions about them. And I was just sitting there I felt like screaming at the monitor. I said, okay, you talked about the diet. You talked about how they got along together. You talked about, getting some exercise. But what you didn't talk about is they're getting a whole bunch of near infrared,
Yeah.
because if you look at the blue zones are that we know of right now are between 37 degrees north and 10 degrees north on the in latitude. And so, kind of like a band through there. But I would argue that what really happens is that those people that are living to be 100, they may have, I'm sure there's genetic, I'm sure there's other things, it's diet. I'm not arguing about that. But one of the things that's universal is they spend a lot of time outdoors with light clothing. And
Yeah.
people have to understand that Fosbury has this really great set of pictures where he takes a T-shirt, a regular shirt, and a a cardigan, and he looks at it at 850 nanometers. The near infrared translates right through all that clothing layers. Now, is it reduced? Absolutely, but you don't have to go. That's why I keep on telling people. I always make the caveat. I'm not asking you to go out buck naked and stand outside in the sun directly. You really want to be in the shade, and you want to use, clothing, because UV and visible are blocked very strongly by clothing. Near infrared is not. So you can go out and you can play in the shade and have a hat on and do all this great stuff. It still is providing you with near infrared. The problem is that we've now developed an artificial environment that we spend most of our time in that has zero. It's not just a little less, it's zero. And, the effect of that, I believe, is harmful. Now, that's going to get me in trouble, but the bottom line is that, we've got enough data, I think, now to say you really do need to get out more. I don't know about down in Australia, but for us, they did a study, and there are people that are in nursing homes that get 5 minutes of sunlight a month,
Yeah, no,
and it's not
it,
right.
it's nowhere near enough. I want to comment on this idea of the necessity for sunlight in terms of our biology, and very much in our society in Australia, the sun is very much demonized, and there's obviously reasons for that, and we have high incidence of melanoma and other kinds of non-melanoma skin cancers. But I really think the baby's been thrown out with the bathwater, and to the degree that you can't go outside without being covered completely head to toe with sun including sunglasses and sunscreens. There was a campaign, I don't know if it's still going, called Slip Slop Slap. But the point that you've made in this first 40 minutes is that there is so much important visible and non-visible light effect on our biology, and as you say, you can still go outside with a t-shirt on and get the benefits of near infrared. But some would argue that you're not adequately, or you're not stimulating something like pro-opiomelanocortin and POMC, and you're obviously not going to be making as much UV vitamin D if you're blocking UVB, and maybe you're not making as much nitric oxide if you're blocking UVA. I guess my answer to that would be simply titrate your exposure based on your Fitzpatrick skin type. If you're really pale and you're from a northern latitude, then you obviously need less direct sunlight before you're burning, or before you're in order to get your needs met. And obviously those with darker skin have to have more sunlight. That brings me to the question that I really want to get your opinion on, which is melanin. And I've talked to Dr. Kruse, and he's talked about melanin and basically as a black hole pigment, and because it's so dark, it will absorb all the wavelengths of visible and non-visible light. And he's presented a data or information that we actually use melanin cutaneously to charge separate water to generate free energy in the form of electrons. Do you know anything about melanin as it relates to near infrared light?
I would. Well, let me back up just a little bit. Can we? I will address your thing about melanin, but could I address the issue of sunscreens
Of course.
in particular?
Yeah.
Yeah, because it's pretty much one of the best examples, or one of the best examples of where the optics really matter. I did a paper way back when that was blocked from publication that basically showed that if you do the optical model, it the free radical generation in the skin is half of it is associated with UV, the other half is associated with visible. And what people don't realize is that when you get a sunscreen, because of uh, the bad optics or bad optics, because the body, in order, I guess what I'm trying to say is, in order for the body to prevent some forms of skin cancer, in particular basal cell carcinoma, which has been on the rise for all these years, even though we've been using sunscreen. What happens is optically is that the visible portion and the UV and the blues, the violets, and the greens localize in the basal cell region of the skin. So, in order for you to use for sunscreen to be really effective, you actually need to absorb in the blues and the violets and the greens, which means you have to put on dark face. So there is what's literally going on is while the sunscreen may help you with melanoma, it actually increases the time that you spend out there outside exposed to blue and greens, because when you put a sunscreen, UV blocking sunscreen on, it literally reduces the sunburn that you're going to get, the erythema. And so you'll spend more time outdoors thinking you're safe, when in reality, you're actually increasing your exposure to the blues and the violets, which are then localizing optically in the basal layer. So, my problem is that, there was a company there in Australia that tried to sell some sunscreens that tried to deal with the blues and the violets. But, we're basically have created this kind of environment that giving false, yes, melanoma is terrible. Don't want to argue with it. Why don't you just wear a hat? That's a little bit better way to do it. Now, when you go down to talking about Kruse's stuff, um, people tend to think about that the melanin is just this dye. You're black, you're white, you're whatever. Actually, melanin is produced as a little granule and is very specifically placed in various parts of the cells around the nucleus. Optically, that's really quite fascinating because they can actually put a higher concentration on the outer portion of the nucleus, so it blocks it. Optically, it allows the rest of the energy to propagate deep in. So one of the things about melanin is that it's not continuous. People think it is, because when we look at somebody, we see a dark skin or a light skin or whatever. The melanin is actually dispersed very spatially and very carefully in the body. And there's been people who have taken melanin and made solar cells out of them. It's possible. Optically, it is interesting that for those who know about the dermis epidermis barrier, it has a lot of modulation on it, where it has all these different ripples and that type of stuff. The melanin is actually put in optically. If I were to design a solar collector, I would put the little granules in a particular location in there that the body does, and it would enhance the effective ability of the melanin to absorb and to do whatever it's doing. Do I know what it's doing? No, I don't know what it's doing. But optically, it is being placed very ideally for it doing something like dealing with water or whatever. So,
Yeah, well, I mean, it seems to me that it's not only protecting, as you mentioned, the granules, so the melanocytes, which are the specific cells that make melanin, sit in that layer, and they have projections that I think they supply about 36 keratinocytes for each melanocyte, and they have these little granules of melanin that they basically, I believe, bleb off, and then they use that to protect the keratinocytes. But what you're mentioning, Scott, is that the function of the melanin is to protect the DNA from ionizing radiation, from ultraviolet radiation, to reduce the likelihood of double-stranded DNA breaks, and then the formation of cancer. But what you're saying is that it's quite possible that we're also using melanin to harvest energy, and maybe
all I'm saying is that optically, if I were to design an optical or a solar collector, putting it in. We do this. I mean, we put these kind of features on solar cells to literally enhance their ability to be more efficient. And it just is very curious that that the body has, your outer skin and then this boundary that is highly modulated. I have a picture in one of our papers where it shows that a solar cell with exactly the same modulation frequencies and all that, and how that enhances the ability to absorb, the near infrared in particular.
Yeah, and
So
it's fascinating, and Kruse says that he is very commonly saying that the skin is the solar panel for the Ferrari engine in our head. So that's what. And look, it's seeming like the lines of evidence are really stacking up in favor of that idea. And I mean that, and then the next question you have to ask is, well, why? Why did we evolve hairlessness? And is one of the reasons so that we could get that more of that solar radiation into our skin and then therefore harness it for energy purposes.
yeah, well, the other thing that you have to realize is that melanin, while it absorbs strongly in the UV and the visible, it tapers off quite radically in the near infrared. And if you actually, or probably one of the few people that have published and measured, but if you take someone who has a high level of melanin, 30-40%, and compare that to someone who has 4 or 5%, redheaded white skin, um, and you look at what happens in the near infrared, there's about a 3 to 6x difference in the absorption, or the absorption that's going on in depending on skin type. But what happens is you get out past about 1100 nanometers, still within the near infrared, we all end up looking the same. We all are dark skinned with white hair. And it's because melanin is dropping out, water is coming in as the main absorber. So what ends up happening is if you were to take a picture of somebody in this shortwave, and you can see it in some of our papers, take a picture in the shortwave infrared, you know, we have this really, all of us have this really dark skin, white hair. Our clothes are white because it doesn't have much water in it. But any material that has water is strongly absorbed. And so it changes once you start looking at these different things and realizing that we all are a little different, but we're all a whole lot of same, then you start to, I think, understand. And, it's difficult because sometimes our politics or whatever get in the way of actually doing real science. And that's what is really quite frustrating. And that's why I love the optics, because at the end of the day, it's a physical effect. It's something you can show, measure, and all that. And it really does illustrate that we're a lot closer to each other than what we sometimes tend to not pay attention or not think.
Yeah. Yeah, no, definitely.
But
And
it also illustrates our differences from a standpoint. If I go down like you or anybody in Australia that's white skinned, you go out, you can get toasted pretty quickly. Someone, with a higher melanin level, they're fine.
yeah,
They have almost no chance of getting melanoma. And it's all because they're adapted they're taking advantage of the benefits of melanin.
yeah,
Now, I'm concerned is that when I do the numbers and look at it, my concern is that for, like up in America, where we've got a large percentage of our population at higher latitudes, they're not getting sufficient near infrared exposure, which makes them having, possibly being affected in ways that we don't really understand yet.
yeah,
And that's what I'd like. That's what I'd like to really get more emphasis going on. Everybody wants to assign it to vitamin D, but there's all this other stuff, and that's what we came to the point of talking about hormones. And because the best antioxidant is melatonin, and that's kind of what we're doing now, is trying to put together the different types of hormones and how they're affected by light.
Amazing. And look, let's talk about melatonin. I want to tie a bow on the sunscreen point. It really what essentially we're doing when we're applying that sunscreen is that we're really looking at a biological system in a very very reductionist point of view, and it really reminds me of blocking HMG CoA reductase with statin medication, in that we've got this incredibly complex system that is running on so many layers, in so many ways that we haven't even fathomed yet. And then we're looking at one lever and we're pulling one lever hoping for a first order effect, whether that's reducing serum cholesterol, or completely blocking UVB with sunlight. And the amount of I guess epistemic arrogance or ignorance about what the second and third and fourth order effects of messing with these biological systems is absolutely enormous. And you gave the example just before of, yeah, you can block UVB with sunscreen, but you're still getting the visible blue and violet in that basal layer, which is responsible for oxidative stress. And as you mentioned, basal cell deaths or incidents going up. So the unintended consequences of blocking the UVB or using sunscreens is that you could paradoxically, if I'm interpreting what you're saying correctly, that you could therefore increase the likelihood of getting something like a basal cell carcinoma. And it's so I feel like collectively we need a bit more humility before we and reperception of the human body, because it's not just a machine with levers that have direct mechanistic outcome for one. You pull it and you get an outcome. There's all these rippling effects because it is a complex system. And really I think the conclusion for me is that taking a step back and honoring our evolutionary biology and having some humbleness and thinking, well, okay, if system is here, it's probably here for a reason. And rather than start fiddling it with it by applying sunscreens, and we haven't even talked about things like oxybenzone and endocrine disrupting
Yeah.
compounds that, there's a whole host of reasons other than just simply the ones that we've talked about that occur as unintended consequences of playing with this system. But this we're transitioning really nicely to what I want to talk about next, which is oxidative stress and melatonin. And what you talked about is that there is this idea that we've got oxidative stress and free radicals happening all around the body, and the amount of light that's hitting these cells, and what you can observe on a cellular level is that the cell is generating a massive amount of oxidative stress just as a routine part of the operation in terms of living. And the way I think about it is like an engine. It's like making a whole heap of heat. But what the melatonin system seems to be, and obviously you're going to expand on this, is that it seems to be like a coolant system, or a very, very, very adapted ability to deal with this oxidative stress at a very, very local level. And it's funny because people in the nutrition diet space and even in popular culture, they think about superfoods, or I'm going to eat this acai berry, or I'm going to eat this a whole bunch of kale leaves, and I'm going to get all these antioxidants. And really, when you understand melatonin, it really makes it all into a bit of a bit of a laugh compared to what melatonin is doing, both at a subcellular local level and systemically, in the systemic circulation. So with that as a bit of a background, why don't you talk to us a bit about melatonin?
Well, I think first and foremost, people need to realize that melatonin has this amazing ability to. It's an extremely good antioxidant, and it's not just that it's an antioxidant. When it oxidizes the first time, it goes to AFMK, which is a great antioxidant, and then it goes down to AMK, which is a great antioxidant. So you get this cascading, and this is one of the things that Russ has been talking about for years. Is that melatonin? Everybody seems to assign it to sleep. I'm going to make it so you sleep with circadian, all that. And I'm not discounting that. All I'm saying is that, and he's been saying, is that the real power. I mean, bear in mind that melatonin's been around for 1 billion years. It's been used on single cell. It exists everywhere, basically, and it has this not only the ability to generate as an antioxidant its metabolites to be an antioxidant, it has the ability to upregulate other antioxidants and affect how they're behaving. Now, what's the latest set of work that we've been doing is so this has been debate's been going on, and Russ has shown that the mitochondria is generating melatonin as well as the pineal gland. All mitochondria appear to be generating it. And so what you end up with is this kind of great debate going on and people taking melatonin for getting better sleep, when in reality, I believe its biggest function is to actually maintain homeostasis for free radical generation at the cellular level and at the systemic level. Now, one analogy I'd make or comparison I'd make is that, you can look at the body selected melatonin as to protect the brain during times of sleep. Why did it do that? Because of its antioxidant capability. So we now have this pineal gland that's generating, in times of low cellular activity, a large amount of melatonin that goes directly around the brain. A little bit of it spills over into the plasma, so where you can actually measure it at night. And that really forms the basis of circadian, theory. So what we've been focused on is trying to understand. We had the ability to say, okay, there's all these free radicals. Something's got to be responding, and melatonin. Russ has been working on this thing showing that melatonin is generated in every mitochondria in every cell. But how do you measure it? Because we can't measure hormone levels on a cellular level. So found this data done by Theron and separately by Zhu, where they actually started measuring melatonin in sweat and in plasma on a scale transiently with enough accuracy that you could actually see what's going on. And lo and behold, what do you find? You find that when we start doing stuff, melatonin levels increase. Doesn't matter whether it's 9 o'clock in the morning, doesn't matter. And so the latest papers are basically showing that, when we do stuff, bear in mind that circadian is actually, they literally make sure that people is measured by making sure people are sedentary in the dark, basically a bedridden condition. What the data we're showing is that when we're doing something, doing anything in life, having sex, doing exercise, going out and swimming in a cold lake, all these things cause a transient response in melatonin that, in my opinion, and based on the data, shows definitively that Russ was right. All of our cells are generating melatonin. Most of the time it's consumed locally to deal with energy production from the ATP production, because it's not totally efficient. But it also provides this ability to have this huge reservoir that was previously not, it's talked about, but if you go through the numbers, you find that there's a lot of mitochondria, and they don't have to generate very much melatonin in order to create this huge reservoir of melatonin that you don't really see until you actually look at some kind of a transient event. And just to give you some rough numbers, typically in the plasma, you'll get 60 picograms per milliliter at night, or maybe a little higher. During exercise, Theron and Zhu and all those were able to show that melatonin levels at 9 o'clock in the morning go up to 200 picograms per milliliter and stay there as long as you're doing exercise. So people's normal response to melatonin is that, okay, it helps me sleep. Well, we're saying, no, it's doing a whole lot more. And, how are we getting it when you're doing this exercise? That's where the debate is at this point in time. We're arguing that it's in the mitochondria. And, melatonin, what it does and how it operates is changing, I guess is what I'd say. People have assigned it a certain thing. And it also shows when you start looking at the transient response that while you can take a supplement, and I, don't discourage anybody to take melatonin. It's pretty safe to do, I suppose. But the body has this ability to clear it fairly quickly with the liver, and so you have to take into account these changes as a function of time. Sorry if that's a little bit confusing, but that's kind of where we're at right now.
Yeah, no, it's fascinating, and I'll make the distinction for the listener that what we're talking about is that there's two separate ways or two separate pools, maybe even of melatonin, and there's the pool of melatonin that is made by the pineal gland, and that's made in response to the absence of blue light. So, if we do a quick detour into circadian biology for people who are listening, when the retinal ganglion cells sense blue light through the melanopsin receptor at, I believe, is about 480 nanometers, then that is the peak absorption for melanopsin. They get triggered, and then your brain switches off production of melatonin from the pineal gland. That is why being exposed to blue light after sunset is going to be so harmful to sleep quality in general and your circadian rhythm, is because you're simply switching off your body's ability to make a melatonin. But what Scott is saying, and the work that he and his team have done, is that that the melatonin is being made in every cell, in every mitochondria locally, not only all the time, but particularly, I believe, on exposure to near infrared light. Is that correct?
Well, it's not just near infrared light, it's exercise, it's doing things. The body, I mean, when you start modeling how many free radicals are being generated in each cell, you're struck by the fact that something's got to be responding. And
Mm.
what we've been able to show now is that when you start doing exercise, you have a ton of mitochondria in your muscles. Those have to generate a lot of reactive or free radicals, and so that what the data shows is that if you actually measure melatonin levels during the exercise event, you will actually see this huge increase in melatonin in the blood that previously, to my knowledge, was basically not even known. I mean, but and it gets back to this issue that how we measure things, and it has a big effect on our understanding. And it's only with, like I say, very careful high frequency sampling that you can actually see this. Because what happens is the body always tries to go back to homeostasis and pulls it back down. So what you see during an exercise event like Theron did or Zoo did, that the melatonin levels rapidly ramp up to a level plateau. And what he was doing was he was actually measuring melatonin in the blood during exercise for a 4-hour session on a stair stepper, long exercise. It literally moved the entire baseline of the melatonin in the blood up. And then immediately, once you quit doing the exercise, within less than an hour, you were back down to baseline. And now the same thing has happened with Gao's work, where they're using wireless bio or cortisol sensors, and we're finding that during exercise, you have this spike in cortisol. All this is not saying that circadian is not right. It's saying that on top of circadian is this other effect that is being done by the body, and it's using melatonin, and it's not just melatonin and cortisol. Anybody can go and run out and do something, and you can, feel like I got a testosterone. So, it's always all these are affecting our hormones on a transient basis, and that's the part that's kind of been missed in the whole thing is that the act of living literally is generating changes in the body's basic chemistry. And what we're finding is that level of change is much larger even than some of the circadian effects.
Yeah.
And why you have to start thinking about, okay, when do I exercise? When do I eat? When do I, because they all affect your cortisol and hormone and these hormone levels in real time. And I think that's the part that people have kind of missed is that the body is doing a whole bunch of stuff that we haven't included in our, as you say, our intelligence level.
Yeah, and
And
look, 2 points to that. One, it makes sense to me that the mitochondria will be making melatonin if this is a 2 billion-year-old compound that is highly evolutionarily conserved across, prokaryotes as well as all the way up to mammals. If they're generating reactive oxygen species at a single cellular level, then they needed melatonin to dampen oxidative stress in their single cells. Well, to me, it makes sense that effect is, or that site of production is going to be conserved if we know that mitochondria were once primitive single cellular organisms. That's the theory of endosymbiosis. That's how we know or we believe that complex life evolved, was when we got efficiency gains by bringing energy production in house in the form of mitochondria. So that's intuitive to me, Scott. That would be the site of their generation. And the other point that I want to make is that if we're generating all these reactive oxygen species, as you say, just as a function of living, then to do exercise, to eat all these things that might add an additional oxidative stress, well, we should do that during daylight hours. We should do that during under exposure to near infrared from the sun to help us produce even more melatonin to dampen down the oxidative stress. I mean, that seems intuitive to
yeah,
me.
yeah, I think it is. And, it's just unfortunate that people can't see what's going on in the near infrared. I get a little glimpse of it because of, I'm doing the models, but it's just literally amazing how the body is doing what it's doing to protect itself. And, people, I don't think I didn't have appreciation for how many things the body is having to deal with at any given one point in time. And that, especially when you start measuring or calculating how many free radicals are be generated in a cell and the distribution of that, you walk out, you go get a sunburn, you can see spatially that that little strap across there is good, not sunburned, and the other is. So things are happening both systemically, but also more at a local level, and they have to be responding. Those cells have got to, by the time the signal comes back that, hey, I've got too much sun on this particular area, send something to help me, it's too late. It had to be. We have to have both the local and the systemic. But what we've been measuring all along has been a systemic long range measurement. Once we start measuring it on a scale that's more appropriate, then and in a way during some of these events, it's not saying that circadian's wrong. It's not arguing that at all. It's saying that there's this other component that we have underestimated. And, I'll go back to the sunburn just from the standpoint of the, you know, I got into trouble, or didn't get in trouble, but I thought it was really interesting. They were talking about trying to stop sunburn. And I said, but you can look at it the other way and say that sunburn is actually a warning signal that you need to get out of the sun. Now you've prevented the ability for the body to tell you you've been in the sun by blocking the UV portion, but you allowed it to so people stay out longer associated with the blues and the violets and thinking that they're fine. So, I mean, as you say, there's all these different things going on in the body that we're not paying attention to, or we're essentially defeating or, preventing them from doing what helps us survive.
Yeah.
And
Yeah. I
so to
mean,
me,
yeah, go
go
on.
ahead. No, I was just going to say that, I think we're at the point now that we're starting to show that the our exposure to sunlight. It's all kind of coming together from the standpoint exercise, diet, sunlight, all these things are playing together. The body's having to deal with them together, or at least it assumes. That's one of the things that people that I keep on trying to say is the body's functions that we've seen assume that we are exposed to sunlight, the entire spectrum of sunlight. When you all of a sudden narrow it down to just a very short amount and you spend all your time there, it has a negative effect on our health, and not surprisingly, you know. So
Yeah. Yeah, and look, we've obviously gone quite technical in this discussion, but really, if you boil it down to doing what your ancestors would have done prior to the invention of the electricity grid, prior to organized civilization, what would hunter gatherer tribes be doing? Will they be grounded outside, all the time, being constantly regulated and exposed to sunlight of and all the visible and non-visible wavelengths of light that we've just been talking about. And look, they didn't need to know the specifics of mitochondrial reactive oxygen species generation and how to dampen that with melatonin. They just lived their life. They hunted the bison. They hunted bison. They made a fire. Sang and they watched the stars, and they enjoyed their lives. And I think what you're doing is so important, Scott, because today's society has become so cerebral and so science based, and there's a whole religion which is scientism, I believe, is it's kind of cropped up.
yeah,
People don't worship religious deities. They worship science as an entity. But essentially, by the work that you're doing, you're really helping us to move the needle, the compass point, or our attention back towards what is essentially deeply ancestral practices, which is simply go outside and be outside, and do that sensibly. But before we finish, and I think maybe this would be a great segue into the final topic of discussion, which is what is happening when people are spending 90% of their time indoors, and we really talked about it a little bit already, which is that they're not getting they're getting zero non-visible light. They're getting zero UV. They're getting zero near infrared or infrared. And what I likened to that earlier was like you're eating a diet that is deprived of 90% of your nutrients if you're not getting all this outside time. So talk to us about what are the characteristics of the light that most people are living under most of the time.
well, as I said, when you walk in, you sit down on the couch and you watch TV. The TV is getting brighter and larger, and we're spending more time in front of it. Our kids are spending more time in front of it. That contains only visible light. It does not provide any near infrared, does not provide any UV. Same thing is true of the lighting systems. We've taken and shrunk the spectrum down to just the visible portion. Uh, that was done based to save energy. Great idea, good from that standpoint. But it ignored, there was zero research into what the effect of that was going to be. And in fact, I'd argue there was a lot of pushback where people before me were saying, hey, this is different. But they couldn't quantify it. To go back to briefly go back to what you were talking about, the humbling effect. It used to be back in the old days that hospitals and all that were designed to actually push people out into the sunlight, and do that. And that was not based on them understanding, as you say, melatonin free radicals. That was based on simply statistics where they observed, Florence Nightingale in particular observed, she was a statistician. She observed that people lived longer when they did certain things. And so if you look at like Ellis Island hospital out here, all the surgery was done under a conservatory window that they could open up. The windows were mostly open, and they used radiant floor heating. They had had water bodies around it to keep the humidity. So what we're talking about here is actually what it used to be. And then all of a sudden, when we got antibiotics and that kind of stuff, we started moving everybody indoors, and sealing off And actually, during that time frame, the idea of using light as a therapy was quite prevalent. And when the drug company, certain parts of the drug companies decided that antibiotics were the wave of the future, they literally shut down some of those practices and made it so that that was considered. So now what you're seeing is, I think, this resurgence of red light therapy, near infrared therapy, people having this conversation and us measuring some of the stuff we're measuring, is really just symptomatic of people having a solar deficiency.
Yeah.
And unfortunately, there's a lot of parts of the population that you can say go out in the sun. They're not going to do it, A, or B, they can't do it. And that's where I have my biggest angst because, I think that, while it's maybe not popular to say, I think we have created an artificial environment that is harmful and unnecessarily so. It's not hard to actually put back the near infrared. It's maybe more hard to put back in UV, but you don't need as much of it on a regular basis. But it's only when we start looking at trying to quantify, this is the engineer in me, you start quantifying some of these effects that you start seeing the opportunity associated with, putting back some of what we used to have, or at least providing people with a methodology where they can have minimum. Try and encourage more kids to go outside in the afternoon. I don't want anybody to go say, "Oh, I told you had to go out and stand out there, in direct sunlight." That's not what we're talking about. The advantage is to be actually in nature in the shade, because in that environment, when you start looking at, we talked about the different parts of the wavelengths. When you look at the different portions, when we're outside in direct sunlight, the visible portion and the near infrared portion from a watt standpoint are about the same with direct sunlight. The minute I walk into the shade, it goes up to 3 times the amount of near infrared to visible ratio. The intensity level drops, but the ratio changes. And that's what we're trying to make everybody understand is that it's the ratio that is important, because this protects you from this. And if you don't get enough of this, and what we did is we took it to 0 for a lot of people, then the body has to find some other way to deal with this. And that ends up being higher oxidative stress. It ends up being, maybe some of the maladies that we see in modern society. Um, you know, and it's not solving everything at once. It's just a part of what you do. You're better off eating a plant-based diet. You're better off doing it. Well, we don't all do that. But this is one thing that we could fix or provide a minimum level without, some big issue.
Yeah, yeah, and I want to make three separate comments. When you talked about we how they removed the non-visible light when they in the lighting industry without consulting anyone or without understanding the long-term effects, it really reminds me of when imposed the cholesterol. That they went on the anti-cholesterol crusade. The 1977 McGovern report basically. Mandated that we should be replacing dietary saturated fats with polyunsaturated fats, and really this is an uncontrolled population based experiment. There was no kind of lead in time. There was just, okay, we've got a hypothesis or we've got a something that we want to do, and we're just going to do it. And the same thing sounds like with the move towards this visible only light, is that there wasn't enough humbleness or humility to think, hang on, well, what are going to be the downstream consequences of cutting out something that's been there for a very, very long time. So I think there are multiple population level kind of uncontrolled experiments that we're running in modern society, especially in the past 3 years, that have unknown and unknowable unintended consequences, and we're going to find out. But I think it's going to be very, very incompatible with human health, and I think a lot of people are going to continue to get sicker. The second point I wanted to make is that um, what we think is a good idea, and this is a kind of lead on point, is that we're going to save energy by putting LED downlights in everyone's houses, and that's going to be a great thing to do. But again, it hasn't accounted for the fact that there was value, or that we have needs that are now not being met, or active harm that's being done by exposing everyone to blue only light. And when you mentioned earlier that the blue and violet gets concentrated in the basal in that layer. Does that, in my mind, I'm thinking about the incidences of skin cancers, and I believe melanocytes do have an absorption peak around 480. Does that imply a mechanism by which isolated blue light that everyone is being exposed to could increase melanoma cancer rates?
Well, all I would say is that you know, they need to run real studies to do it. But all I'm
Mhm.
saying optically, that is what is happening is that the majority of the photons that are going in the blue and the violet are localizing in that basal layer. They and that by preventing the body from telling you it's time to get out of the sun, people could be spending more time in the part. And this is well known. Zostro did this study years ago, and it's really kind of what we use for some of our models, where he showed, and he was working for a cosmetic company, and he showed that you can take a piece of skin, put it out, expose it to UV, expose it to the near infrared or to the visible portion, and those two samples will have the same number of free radicals in them. So it's not like UV is the bad guy doing everything wrong. We actually need UV, but the visible is also contributing to the amount of free radicals in that particular region, and optically, that's where the majority of them are absorbed. So, but
How far into the skin does visible like blue light penetrate? Because we
uh,
did we
it,
mm,
yeah, I mean, it's a little bit of a functional wavelength, but if you look at like Eddie or anything, you can say that 99% of them fall within a millimeter into the skin, photons, and that's based on the absorption characteristics of skin in the visible range.
mm,
So it just, like I say, we did a model and showed it that there was a higher concentration in that basal layer, and might be an issue. It might be a reason why that people with light skin, men with light skin color still are getting increasing levels of basal cell carcinoma. Somebody's going to have to run the test to actually prove that and
yeah,
all that.
yeah.
But
Great. Well, all right. Well, let's wrap this up. And I think that a good way to kind of finish this conversation is basically what people can do, or how you would like to see society change from an optics and a light point of view, to offset, mitigate, reverse some of the problems that we've just talked about, when in terms of reducing everyone's light diet to 5% of what ancestrally we would have been getting. So what can people do, and what can companies and society do at large?
well, I think that as we've been talking about with um, sunscreen, the lighting industry is dealing with now a whole bunch of unintended consequences. You know, and it's not just near infrared. What happened is we created a technology where people could efficiently generates visible light. Now, I believe that nobody at the time that they were doing that came to the conclusion that if everybody had the ability to put more light without costing a bunch of energy, they were going to put more lights out. So what's end up happening is not only have we eliminated the near infrared from visible daytime, we've replaced it with a whole bunch of light, especially in the blue region, at night, which is leading to the artificial light at night. I'm a dark sky advocate, basically. And so, but I think it's really along the same lines as I said with the sunscreen. Nobody intended that we would, yeah, they wanted to sell light bulbs, don't get me wrong, but nobody intended to have this huge explosion of light at night. I've got a neighbor down the way that she has the brightest blue thing that runs all night. I go up and say, turn that stupid thing off. But that's what's happening is that light is where we've eliminated the portions of sunlight and essentially the amount of sunlight we're getting during the day, and we've moved it into the night, and it's essentially affecting all life forms. I don't know about you down there, but I would always go out with my grandkids to watch the fireflies. Fireflies aren't around very much anymore around our neck of the woods. Now, it could be a lot of reasons, but, I think that we need to take a step back, as you say, be a little bit humble and understand that what we're doing has a whole bunch of unintended consequences that nobody wants the planet to die from global warming and all this other stuff. We're all trying to do it, but at the same time you can do it stupid, you know and that's what's the concerning part is that as an engineer, I'm looking at the numbers and I'm saying, wow, we really did change stuff a lot, and do we know what it's going to do? And that's kind of where I'm coming from in the whole thing.
Yeah, no, and it definitely, and I agree with you a lot, Scott. I think that we really need to walk back some of these changes that we made from a societal point of view, in the face of what is so much metabolic disease, cancer, behavioral issues, and so many of them stem back to disruptions of our light, of our naturally evolved light environment. And I just recorded a really great podcast with Sarah Pugh, for those who want to delve a little bit deeper, and Jalal Khan, into the exact kind of pathologies and diseases that are kind of are linked to perturbations in our light environment. But from a whole high level view, I think reducing the amount of LED, blue lit downlights that are in a house. I mean, look in here in Australia, there's massive tracts of housing developments that get put up, within 3 months. They all look identical. They're all cookie cutter, and you go inside them, and their harshest, starkest laboratory white light, is emitted from all these downlights in the ceiling. And people are turning them on, because they just use their stock standard, the lights that come with the house, and not realizing what effect that is having, on their biology. So that might be a good point to kind of talk about what you're doing with your company in terms of trying to balance out the artificial light spectrum.
Yeah, and our company, we're basically developed a light source that it's not very complicated. I believe in keeping it simple. Where LEDs are very good at generating visible light. They do that really well, with a high efficiency. They're terrible at generating near infrared. The old filament bulbs that everybody learned to hate is the most efficient method of generating near infrared. And when I talk about a filament bulb, I'm not talking about a light bulb. I'm talking about the little grain of wheat ones that you used to have in your flashlight, all that. Well, it turns out that if you use the filament bulbs to generate the near infrared, you drop the temperature of the filament, and the lifetime of a incandescent goes out to beyond that of an LED. Now, the LEDs, so what we do is we have a light source. It's really quite simple, where we have a combination of LEDs to generate visible, and and use the filaments to generate the infrared. And we do that in a way that mimics basically a shade condition, where it's a 3-to-1 near infrared to visible as far as optical watts. So that's what we generate. We make. It's just a little screw-in light bulb, runs off of 48 volts or 120 volt AC. And the cute thing is that by doing that, it basically gives us the ability to um, make improve our make it simpler for the control systems associated with lighting, so we can do a larger dimming range. We have a better uh, power factor and other things. But just in general, that's what we're been putting out there and trying to sell in the form of desk lamps and things like that. Because I believe that we don't have to relight everything. But as you say, this idea that you can put these high bright blue ones sitting up in a can light and everybody turns on, and you have this harshness that is inappropriate. You know, you need to be able to get to the point that you can have something that has some of the near infrared content in it to put by your workstation or to put with your children, when they're reading a book. It used to be that we'd sit around and, either have a little campfire going or have, be reading under an incandescent or candlelight or whatever in the old days. And there was an advantage to that. It basically set you up for better sleep. I would argue that what we do as far as the near infrared is just as much as important in your sleep patterns as, people are doing. Because what's really happening, the lighting industry has said, okay, we're going to shrink everything down from 400 to 700 nanometers. And in fact, they're really pushing more like 620. So that'll we can make everybody think that's white. But now all of a sudden, we're having some problems with people sleeping. I don't remember having a lot of troubles sleeping when I was under incandescent lighting. I do have problems. People are having a lot of problems with this shrunken, thing. So, and they've got a problem because if they add in the violet, add in the reds that make up, gets closer towards what we want, the efficiency goes in the toilet. So, they're kind of stuck. And, what our light does is let you still meet the DOE requirements for energy efficiency, but it gives you the entire spectrum out to about 3,000 nanometers, simply because the little filament bulbs that we're using are so efficient at generating the near infrared. So,
Yeah,
and
I
there's
mean,
some other electrical advantages.
it sounds great, and look, it again. It reminds me of the the goal is to save energy and to prevent climate change, but the two biggest, I guess, centralized top down movements that are being pushed to achieve that end from an optical point of view are and from a dietary point of view are massively harmful to human health, and that is simply using LEDs on the visible only, which is what we've just spent an hour and a half talking about, and then also this whole idea of a plant-based diet, which is highly deficient in essential nutrients. So it's this perverse kind of bizarro world where, in order to save the world from climate change, we're all having to sit under profoundly alien light sources, eating a profoundly nutrient deficient, monocropped plant-based diet, and that's supposed to be kind of everything that we do to save the planet from climate change, which is essentially making people incredibly unwell because our fundamental biological needs from a dietary and a light point of view aren't being met. So I really take my hat off to you, Scott, for doing the work to develop a product that is going to help people kind of, I guess, fill those needs back in. And it sounds like an excellent tool. I guess it's all about tools, because we can go out into the wilderness and live like Ugg the caveman, and have a perfectly regulated circadian rhythm, and max out our melatonin synthesis all day, every day. But that's not really compatible with modern society. So I think using tools like what you're designing and selling, is a great intermediate way, because people could simply put a light on their desk, as you mentioned, and get some of that near infrared, and not have the as destructive effect on their biology, their circadian rhythm, but their ability to make melatonin. So
Well,
that's really exciting.
yeah, and I think that there's a good portion of it is people need to start getting educated and aware of what's going on. You know, most people they have no idea, And, rightfully so. We all have our lives to live. We have things going on. And sometimes the solution is not the perfect solution. Sometimes the solution is something on the in between.
Mm.
And that's just kind of what we're trying to focus on, is to say, okay, start a process, because it's not just the lighting. The architects there was a discussion I had a while back with one of the glass manufacturers for architectural glass, and he said, Scott, every time I was explaining the near infrared, and he said, that kind of explains it. We've been doing this experiment with these hospitals, and the more we extend the reflected range or window out into the near infrared, the better the results get. There's studies all over the place that simply being near a window in a hospital is better for. There's lots of ways we can start doing it, but if nobody knows about it, nobody does anything, then they're going to always go for the energy savings. And I would argue that that it's it only takes probably less than a 1% improvement in productivity or time in the sickness, the reduction in sickness, to wipe out any energy savings that they are hoping to get. And quite honestly, we really haven't had that much in energy savings if you actually take into account the increased amount of areas that we're lighting. We used to not light. I grew up in Kansas. You could look out across the area and you could see one barn light for every house. Now it's like everything is lit, and it's overwhelming. Some of the measurements are showing that we're increasing the light at night by 10% every decade or something like that, and
Yeah.
it's really part and parcel of this whole thing, that people aren't aware that there's another thing going on that you ought to take into account.
Yeah, and maybe in the future people will view using a massive LED light at night as the equivalent of having a really inefficient diesel generator spew out, smoke into the atmosphere. Because that's what it
Yeah,
is. That's an analogy about the externalized negative externality of running these devices and this technology, is that you're really polluting the commons by putting your really blue light on in front of your neighbor's window, and unless they have blackout blinds and wearing a sleep mask, it's very consequential. The
yeah.
um the other point I
One quick little thing is that there's a guy named Bartholomew, a lighting designer, and his thing is that he's been trying to, and I wrote a paper with him and we published it on the effect on the Black community. And one of his things that he talks about is that in New York City, where they were having so much crime, their solution was to take and put in uh, generators with high intensity lights for the parks and the other areas to try and cut down crime. And I'm looking at it, and he's the same, agrees. Is that, I mean, in what world do we think it's a good idea to run a bunch of generators and have light on all night, to try and make people safer, you know? And for some reason, we're in this topsy turvy world where we come up with these kind of conclusions and don't take into account the effect it has. It's not just physical; it's mental. There are all kinds of issues that improper lighting is having on our health.
Oh, undoubtedly. I mean, I see patients in my clinic, and the sickest ones from a mental health and psychiatric point of view invariably have an absolutely completely deficient light environment, completely sunlight deficient. Serum vitamin D is low, which is what I look as a proxy of their sunlight exposure. Their circadian rhythm is completely tanked and inverted. Often they're going to sleep at 3-4 a.m. because they're on the computer playing games till the early hours of the morning, and it's very consequential. And as you said, Scott, people aren't really aware of it yet. But I mean, that's the purpose of this discussion and other discussions. On the and the other point I just want to make about also about the light environment and hospitals is that Kruse has made the point that if we put casement windows, so opened up casement windows in hospitals, that would be something incredibly simple that would be able to expose patients to natural spectrum. That wouldn't be that difficult. And I've worked in hospitals for 4 years, and they're profoundly profoundly unhealthy in terms of the light environment that you're going to get in a hospital. And the other interesting thing is quartz, which is obviously able to uh, allow all forms of visible light and non-visible, and UV as well, I believe. So maybe putting quartz on the neonatal intensive care, the NICU, little cubicles for the neonates, the premature babies, to allow a bit of UV in as well. That's a cool idea too.
Well, with my kids, they have a little jaundice. You put them up in the window. Well, now you can't put them into the window because it's UV blocking and near infrared blocking. So they no longer recommend to do that. And it is. I believe the hospital. I would argue, based on the stuff we're done with cortisol, that hospitals presently are designed to bring their patient in with the worst, high elevated level of cortisol. It's always scary to go to the hospital for us non-doctors, but the reality is that you walk into a hospital, and rather than trying to reduce cortisol, is a very important hormone and all that, but it basically suppresses the immune system, when it's at elevated levels. That's what it does to help you fight or flight. But everything that we do now in hospitals, I would argue, is making it more likely that that patient is an elevated level of cortisol rather than a lower, more melatonin type base. And that's just two hormones. There's hundreds of hormones that we have no clue. The only reason I was able to do the data we had is because we'd spent so much time on circadian, where we had some measurements that actually were fast, good enough to use for this set of papers. And so there's so much to learn. As you say, we need to be very much more humble on what's going on. And I believe that at some point in time, why wouldn't you just have a little atrium area that you bring people into that has natural sunlight coming in, and kind of set them up to good music, a little, have a carrot. I don't, I'm just saying that there's no reason that we can't use the body's defenses. There's this one thing I was looking at, the African American population in Chicago, or in general, had 40 times the death rate of the population in sub-Saharan Africa. Now, sub-Saharan Africa didn't have the vaccines we had, didn't have all this other stuff, as far as healthcare, and yet there's this huge difference. And I would argue that in part it's associated with a more exposure to sunlight in those areas. And the black population is probably the leading indicator, because of the way light actually, our models show that it takes quite a bit more exposure for them to get the same stimulus that we get. And so I think there's a lot to be learned, and I'm hoping that people will start digging into it a little bit deeper on the research side, because really all we're doing is putting back what nature used to provide. I'm not trying to, sell everybody they have to get more, than what nature provided. And that's why we design our lights to do the 3-to-1, and then when you switch it into another mode, it's dimmed down to where it's more like coals of from a fire.
Yeah,
Because
amazing.
that's the
Yeah, I mean, I think that's the two themes of this discussion is, let's have some collective scientific and epistemic humility about how we're conceiving the natural biological systems, and let's try and get back to nature, because Mother Nature did it the best. We are sculpted by light, and we're sculpted by Mother Nature and the natural light frequencies. So if we can get outside as much as we can, and use the sun as safely and as we've just talked about, then I think people are going to be able to prevent disease and definitely heal, which is not
yeah.
what the current setup is really aligned to. So Scott, thank you so much for coming onto the podcast. Where can people find out more about your work? Where can they follow you online, and where can they buy some of your lights?
You can buy the lights from niralighting.com, Nira lighting.com. We're a small little company, so we're just trying to start building up inventory to get it. So please be patient.
Do you ship to
You know,
Australia?
yeah, we can ship to Australia. We'll send you the shipping bill, but that's the thing. But for Australia and the UK, because your voltage differences, we just provide you with a plug-in module, so it's a wall wart type thing, and you got a couple versions. You can do one where we provide you with the lamp, and the other where you can modify your existing lamp to do that. And then you know, uh, if you want to look at any of my work, um, Russ was extremely patient. Took an optical engineer and told him how to actually write a medical paper with all the references. So we've done that. There's 3 or 4 of those out there that I'd suggest. Roger talks about some of those papers. It's really, mainly associated with melatonin and the optics of the body, and now it's also throwing in some of the. But most of the work I've done is I posted on LinkedIn. So if anybody wants to friend me on LinkedIn, they can go back and look at the papers. It's a stack about that thick because I'm long winded. So they may have to dig through a few of them, but I think that like I say, if they would like to, and it's interesting to watch because while I understand the reasons behind peer reviewed papers, and we do that, sometimes LinkedIn is a much more open conversation and a broader conversation with more diversity, as you say. You know, I really believe that everybody's got a place at the table. The architects, the phototherapy people, all this kind of stuff, because we're really just trying to create an environment where people can live the optimum life.
That's
So
it. And that's my goal, to help people live their optimal, most thriving life. And yes, I agree with you. There's quite a lot of drawbacks or problems with the peer review process. It's obviously it can be great, but it can also prevent inhibit the free flow of ideas, and especially when financial interests get involved. But look, Scott, thank you so much. I will include all those links to your papers and social media, and online store in the show notes, and so people can engage and get in touch with you. So yeah, thanks again for your time, and have a great night.
you too. Thanks.